Most organizations think enterprise AI looks like this. User talks to a bot, the bot talks to a model, the model gives an answer. That may be enough for a demo, but it is not enterprise AI architecture. A Copilot bot, chatbot, agent, Teams bot, Power App, AI assistant, or web application is only the user interface. The real architecture is everything underneath that makes the AI capability reusable, testable, governable, secure, observable, and safe enough to survive production. One of the biggest mistakes I see right now is that companies are confusing the AI interface with the AI architecture. They see Microsoft Copilot, they see ChatGPT, they see custom copilots, agents, and chatbot demos. And the mental model becomes very simple: user, bot, model. That is not wrong as a demo pattern, but it is dangerously incomplete as an enterprise architecture pattern. A Copilot bot can be a useful interface. A chatbot can be a useful interface. An agent can be a useful interface. A Power App can be a useful interface. A Teams bot can be a useful interface. But none of those should own the enterprise architecture. Because beneath that visible interface, the business still needs a lot of engineering structure. You still need to know what business capability is being exposed. You still need to define the unit tasks inside that capability. You still need input contracts, output contracts, validation rules, security context, logging, testing, monitoring, versioning, fallback behavior, cost controls, and human review rules. If you do not design those layers intentionally, they do not magically disappear. They get hidden. They get hidden inside prompts. They get hidden inside workflow logic. They get hidden inside connectors. They get hidden inside one-off departmental applications. They get hidden inside assumptions that nobody wrote down. And that is where enterprise AI starts getting fragile. The problem is not that Copilot bots are bad. The problem is treating the bot as if it is the architecture. That is like saying a front door is the house. A front door matters. It is how people enter the building. But the front door is not the foundation, framing, electrical system, plumbing, drainage, load path, inspection process, or building code. The bot is the entry point. Enterprise AI architecture is the structure underneath it. The blunt version is this: a Copilot bot may get the demo approved. Architecture determines whether the system survives production. Think about a house. When most people look at a finished house, they see the visible parts. They see the siding, they see the roof, they see the windows, they see the paint, they see the cabinets, they see the flooring, they see the countertops. But the house does not stand because somebody picked nice cabinets. The house stands because the invisible engineering was handled correctly. The soil had to be considered. Drainage had to be handled. The foundation had to be designed. The framing had to carry the load. The roof had to be tied down. The plumbing had to be routed. The electrical system had to be safe. The building had to pass inspection. The visible house sits on a lot of invisible engineering. Enterprise AI is similar. The visible layer may be a Copilot bot, chatbot, agent, Teams bot, Power App, web app, or internal business application. That is what the user sees. But the useful and dangerous parts live underneath. Where does the data come from? Who is allowed to access it? What business rule applies? What happens when the model is uncertain? What happens when the model is wrong? What gets logged? What gets reviewed? What gets tested? What happens when the vendor changes the model? What happens when costs increase? What happens when a better executor becomes available? What happens when the workflow needs to change? Those are architecture questions, and if the answer is the prompt handles that, then you do not have architecture, you have hidden logic. That may be fine for a prototype. It is not good enough for enterprise production. The deeper point is this: enterprise AI is not just a user experience problem. It is not just a prompt engineering problem. It is not just a model selection problem. It is an architecture problem. And the architecture has to account for business capabilities, unit tasks, contracts, execution choices, routing, security, governance, testing, observability, and operations. A good AI demo shows the front door. Enterprise AI architecture makes sure the building does not collapse. Now let's talk about what happens if companies do not solve this architecturally. The easiest path is this. Every department builds its own AI tool. HR builds an HR assistant. Finance builds a finance assistant. Legal builds a legal assistant. Sales builds a sales assistant. Operations builds an operations assistant. IT builds an IT assistant. Customer service builds a customer service assistant. At first that feels productive. Everybody is moving fast. Everybody is experimenting. Everybody has their own AI use cases. Everybody gets a demo. But over time this turns into the 500 AI app problem. Now every department has its own prompts, its own model choices, its own connectors, its own data assumptions, its own security assumptions, its own logging gaps, its own cost behavior, its own business rules, its own versioning problem. And AI sprawl is worse than normal application sprawl. With normal application sprawl, at least a lot of the logic is visible in code, databases, stored procedures, APIs, configuration, and workflows. With AI sprawl, a lot of the logic is hidden inside prompts, embeddings, model behavior, agent instructions, tool calls, and undocumented assumptions. That makes it harder to test, harder to audit, harder to govern, harder to secure, harder to change, harder to explain. And eventually leadership asks a reasonable question. Why do we have 500 AI apps that all do slightly different versions of the same thing? Why does every department have its own summarization logic? Why does every department have its own classification logic? Why does every department have its own approval logic? Why does every department have its own exception handling logic? Why does every department have its own security interpretation? That is not enterprise AI architecture. That is unmanaged AI sprawl. The better model is not 500 disconnected AI applications. The better model is reusable enterprise AI capabilities. For example, summarize policy, classify ticket, extract invoice data, review contract clause, generate customer response, route service request, detect exception, score risk, recommend next action. Those should be capabilities that multiple interfaces can consume. A Teams bot can call the capability. A Power App can call the capability. A web application can call the capability. A workflow can call the capability. An agent can call the capability. An internal API can call the capability. That is the architectural shift. Stop thinking every department needs its own AI app. Start thinking, what reusable enterprise capabilities do these interfaces need to consume? Because 500 disconnected AI applications is not enterprise AI architecture. It is unmanaged AI sprawl. This leads to the next principle. Interfaces should not own intelligence. A chatbot is an interface. A Copilot bot is an interface. A Teams bot is an interface. A Power App is an interface. A web app is an interface. A mobile app is an interface. An agent can also be treated as an interface or orchestrator. But the interface should not be where the enterprise business logic lives. The business logic should live in stable, reusable, governed capabilities. Here is a simple example. Suppose the company wants to automate part of invoice approval. The bad pattern is this. The Power App has some invoice approval logic. The Teams bot has different invoice approval logic. The Copilot prompt has another version of invoice approval logic. The workflow has another version. The finance assistant has another version. Now you have duplicated logic everywhere. If the approval threshold changes, you have to find every place that logic exists. If the exception policy changes, you have to update every interface. If the audit requirement changes, you have to retrofit every app. If the security model changes, you have to chase the logic across prompts, apps, workflows, and connectors. That is fragile. The better pattern is this. All of those interfaces call the same back-end capability, approve invoice capability. That capability may contain several unit tasks: validate invoice, check approval rules, detect exceptions, compare against purchase order, check vendor status, determine risk, route for review, log the decision. Now, the interface is not the owner of the business logic. The interface is a consumer. That distinction matters because interfaces change. Today, it may be a chatbot. Tomorrow, it may be a Teams bot. Next month, it may be a Power App. Next year, it may be embedded inside a line of business application. After that, it may be exposed through an agentic workflow. Interfaces are disposable compared to capabilities. Capabilities are infrastructure. That is especially important in the Microsoft ecosystem because companies may use a mix of Copilot Studio, Power Platform, Teams, SharePoint, Dynamics, custom .NET applications, Azure Functions, Azure OpenAI, semantic kernel, and internal APIs. The architecture should not force every interface to reinvent the same intelligence. The interface should call the capability. The capability should own the logic, the contracts, the routing, the testing, the logging, and the governance. Your chatbot should not be where your enterprise business rules live. Interfaces are disposable. Capabilities are infrastructure. Now let's walk through the vertical slice. This is where enterprise AI becomes wider and deeper than most organizations initially realize. At the top, you have the visible interface layer. That could be Copilot, chatbot, agent, Teams bot, Power App, web app, mobile app, workflow, internal business application. That is the layer users interact with. Underneath that, you need the business capability layer. This is the reusable enterprise AI capability, not a bot, not a prompt, not a model call. A capability, something the business can name, reuse, own, test, govern, and improve. Underneath the capability, you have the task layer. Most capabilities are not one big blob of work. They are made up of bounded unit tasks. For example, a contract review capability may include extract clause, classify clause type, identify missing language, compare against standard terms, score risk, recommend escalation, route to human review. Each of those is a unit task. Underneath the task layer, you need the contract layer. For each unit task, what are the inputs? What are the outputs? What validation rules apply? What security context is required? What data can the task access? What format should the response follow? What confidence score is needed? What failure behavior is acceptable? That is what keeps the task from becoming vague prompt soup. Then you need the complexity decision layer. For each unit task, you ask, what is the lowest complexity method that reliably solves this task? Not every task needs an LLM. Not every task needs generative AI. Not every task even needs machine learning. Some tasks need deterministic C# code. Some need business rules. Some need statistics. Some need optimization. Some need vector similarity. Some need ML.NET. Some need an LLM. Some need Azure AI services. Some need human review. Then you need the execution layer. This is where a capability execution router chooses the approved executor for the task. Then underneath that, you have the implementation layer, C# code, rules engine, statistics, optimization, ML.NET, semantic kernel, LLM, Azure AI services, human review. Finally, you need the operations layer, testing, logging, monitoring, versioning, governance, shadow mode, rollback. This may sound like a lot, but the complexity already exists. The only question is whether the complexity is managed or hidden. If you do not design the contracts, the assumptions still exist. If you do not design the routing, the execution choice still gets made somewhere. If you do not define logging, the system still behaves in ways you cannot see. If you do not define governance, people still make changes. If you do not define rollback, you still need one when production breaks. So the choice is not simple architecture versus complex architecture. The choice is managed complexity versus hidden unmanaged complexity. Enterprise AI is much wider and deeper than a bot connected to a model. Now let's talk about one of the most important engineering principles in enterprise AI. Use the lowest complexity method that reliably solves the unit task. This sounds simple, but a lot of AI projects violate it immediately. They start with the model. They ask, which LLM should we use? Should we use GPT? Should we use Claude? Should we use Gemini? Should we use open source? Should we use agents? Should we use a vector database? Those may be valid implementation questions later, but they are not the first question. The first question should be, what is the unit task? Then, what is the simplest approved method that solves that task reliably? I think about this as a complexity ladder. At the bottom, maybe a human still does the task. Next, maybe the task can be solved with deterministic C# logic. Then maybe business rules. Then statistics, then optimization or operations research, then linear algebra or similarity search, then ML.NET or custom machine learning, then LLMs or generative AI, then specialized managed AI services like Azure AI Document Intelligence or Azure AI Language. And sometimes, after all of that, the answer is still human review. The point is not that one level is morally better than another. The point is that higher complexity usually brings higher cost, higher testing difficulty, higher governance burden, higher operational uncertainty, and more failure modes. So complexity should be earned. If an invoice amount exceeds an approval threshold, you probably do not need an LLM. That is a rule. If the invoice amount is over $10,000, require manager approval. That should probably be deterministic code or a business rules engine. Do not send that to a generative model and ask, do you think this invoice needs approval? That is unnecessary complexity. On the other hand, if you need to summarize a dense contract clause, an LLM may be the right tool. If you need to extract data from scanned invoices, Azure Document Intelligence may be the right tool. If you need to predict churn, statistics or ML.NET may be the right tool. If you need to find similar documents, vector similarity may be the right tool. If you need final legal approval, a human may still be the right executor. This is the engineering discipline that gets lost when organizations say, we need AI. The goal is not to use the most advanced tool everywhere. The goal is to solve each unit task with the lowest complexity method that reliably meets the business requirement. Do not use an LLM when an if-then rule solves the problem. Complexity should be earned. Once you define the unit task and choose the appropriate complexity level, you need a way to operationalize that decision. That is where the capability execution router comes in. A lot of people talk about model routers. A model router chooses between models. Maybe it chooses between a cheaper model and a more expensive model. Maybe it chooses between a fast model and a more capable model. Maybe it chooses between different vendors. That can be useful, but it is too narrow. In enterprise AI architecture, the more important concept is a capability execution router. A capability execution router does not just choose between models, it chooses between approved execution strategies. For one unit task, the best executor may be deterministic C# code. For another, it may be a rules engine. For another, it may be statistics. For another, it may be ML.NET. For another, it may be semantic kernel orchestration. For another, it may be an LLM. For another, it may be Azure AI Document Intelligence. For another, it may be human review. This matters because consuming applications should not be hardwired to model names, vendors, or implementation details. The application should call a stable capability. The capability should handle the execution strategy. For example, imagine a contract review capability. The application calls review contract capability. Inside that capability, different unit tasks may route differently. Clause extraction may use an LLM. PII detection may use Azure AI language or another approved service. Risk scoring may use ML.NET. Approval thresholds may use deterministic C# rules. Final legal decision may require human review. The application should not need to know all of that. The application should not care whether the risk score came from ML.NET, a rules engine, or a managed AI service. The application should receive the contractually defined output from the capability. That gives the enterprise flexibility. You can change the executor without rewriting every interface. You can test a new model without changing the Power App. You can move from one vendor to another without changing the Teams bot. You can benchmark a cheaper executor without exposing that complexity to the user experience. You can add human review for high-risk cases without redesigning the whole application. The router protects applications from model volatility, cost volatility, vendor volatility, and implementation volatility. That is a major architecture principle. Stop binding applications directly to model names. Bind applications to stable enterprise capabilities. Let the capability manage the execution strategy. An enterprise AI router should not just choose a model. It should choose the safest, cheapest, most reliable approved way to execute the task. The final point is production discipline. Enterprise AI cannot run on hope. You do not switch enterprise AI models because a vendor says the new one is better. You do not change prompts casually in production because a demo looked good. You do not move a task from deterministic rules to an LLM without testing the behavior. You do not replace one executor with another without measuring quality, cost, latency, failure rate, and risk. Enterprise AI needs controlled operations. That means benchmarks. You need historical examples. You need expected outputs. You need edge cases. You need failure cases. You need examples where the old system performed well. You need examples where the old system performed poorly. You need examples that represent real business risk. Then you need regression testing. If you change the model, prompt, rules, retrieval method, or executor, you need to know what got better and what got worse. Then you need security review. Does the new executor access the same data? Does it preserve the same permissions? Does it introduce leakage risk? Does it change retention behavior? Does it expose sensitive information in logs? Then you need shadow mode. Shadow mode means the new executor runs beside the current production path without making the live business decision. You compare the outputs. How often does it agree with production? Where does it disagree? Is it better? Is it worse? Is it cheaper? Is it slower? Does it fail differently? Does it require more human override? Then, if the results are good, you shift limited traffic. Maybe 5%, maybe one department, maybe one region, maybe one low-risk workflow. Then you monitor quality score, latency, runtime cost, failure rate, human override rate, escalation rate, security exceptions, user satisfaction, rework rate, and if quality drops, you roll back. That is what production-grade enterprise AI looks like. Not because we want bureaucracy, because AI systems change, models change, costs change, vendors change, prompts change, business rules change, data changes, user behavior changes. If your AI architecture cannot handle change, then it is not really enterprise architecture, it is a fragile implementation. Enterprise AI production changes should happen through benchmarks, regression tests, security review, shadow mode, controlled rollout, monitoring, and rollback. not hope. The main point is simple. Enterprise AI is not about throwing a Copilot bot at a business process. The bot is only the visible layer. Real enterprise AI requires stable, reusable, governed capabilities underneath the interface. Then each unit task should be solved with the lowest complexity method that reliably meets the business requirement. A bot may get the demo approved. Architecture determines whether the system survives production. You can explore more practical enterprise AI resources at ain.net.com. Thanks for watching.